Okay, so what's the limit for your theta? Can you anyone tell me? For theta?
0 to 2 pi.
Yes. How about R?
1 to 1.
What to 1?
0.
Yes, 0 to 1. Right. Okay. And the function is 1 minus R squared and R dr d theta. This is much easier. Okay. So whenever we have circle region, we like to use polar. Next, okay, this is the exercise problem. This should be very easy to evaluate. I think the answer, I can give you the answer very quick. 0 to 2 pi, here R minus R cube, dr d theta. And 0 to 1. So should be 1/2 minus 1/4 and times 2 pi. So the answer should be pi over 2. Okay, so the volume is pi over 2. That's the final answer. If we do Cartesian, it will be much difficult. Okay, very difficult. Now let's take a look at the next example. Example 2. Find the limits of R, the double integral. So this means it is in polar, okay, in polar, because it's FR theta, right? And the R lies inside the cardioid, which is R equals 1 plus cosine theta, and outside R equals 1. Okay, so just find the boundaries for R and theta. But firstly, we need to know how to sketch the graph. Okay, we need to have the graph. If we have the graph, we can find the boundaries. So firstly, let's see. It's in 2D. R is in 2D, right? So inside cardioid is, we learned this in Calculus 3. It's like a heart shape, okay, like this one. This is 1 plus cosine theta. Don't worry too much, everyone. In the quiz or midterm, I will give you the graph. You don't need to sketch the graph. Okay? But when you do the homework, if you see some problem like this, you can use calculator or you can Google the graph of the function. And R equals 1, so it's here. R equals 1 actually is circle. It's a circle. Let's draw. Here's 1. Something look like this one. Okay. And let's inside that 1 and outside this. Okay. So from the graph, we can see the angle is like a negative pi over 2 to pi over 2, right? But we like to double check, okay? It's like an intercept of those two functions. So we set those two R equal to each other. So you can see 1 plus cosine theta equals R equals 1. So we set them equal to each other. Solve for theta. So you can see cosine theta here equals 0, and what is theta? Can be plus minus pi over 2, right? Okay, so the angle here, negative pi over 2, and the angle there is pi over 2. Okay. And let's see R from what to what. Do you still remember why I say R1 to R2, we follow which direction? Do you still remember which direction we need to use? We use the ray direction, right? So what is direction? Like this is R direction, is that right? So what is our R1? Can you tell me what is R1? R1 should be,
R is equal to 1?
yes. Okay, so if you write down the limit, it's kind of like theta from negative power 2 to power 2, right? And R from R1 to R2. So R1 should be 1, which is circle, and the outside is 1 plus cosine theta. Are you okay, everyone? Find the limit for R and theta. Something like this. Okay. Let's try this one. I'm going to ask you to sketch the graph. R is on the left of y-axis between two circles, and those two circles are x squared plus y squared equals 4 and x squared plus y squared equals 1. Please sketch the graph by yourself and then find the limits or the boundaries for r theta.
So I had a question regarding the homework.
Yeah.
Do you want us to evaluate for all of them, or can we just set some of them up?
It's better to evaluate. You can at least half, okay? If you
Okay.
think it's very complicated, but you know, sometimes you may see some problem like this or some problem like that. We need to know how to evaluate them, simplify.
Okay.
Yeah,
Sounds good.
but you can focus more on setting up. If the integral is very complicated, you can skip. Do you know how to sketch the graph of this problem? We have two circles, right? Let's see. Resin, are you done with this problem? No? Okay. Let's see. Did you get the graph? I'm going to, on the left side of y-axis, so should be this one, right? Okay. So you can see theta from what to what? Theta should be
pi over 2 to 3 pi over 2.
very good. Pi over 2 to 3 pi over 2. Okay, so the left part are from what to what? One, two.
2.
Yes. 2. Yeah. Okay, this one. So next, why we do this kind of thing? Because next we're going to find the area of some polar curves. So let's take a look. Okay, area. Let's think about our double integral. So double integral is given by this, right? Double integral. Okay, and this actually is the limit sum of fxi, yi, or xk, yk, doesn't matter, and delta x, delta y. Oh, we can just write down delta a, right? Delta a. Okay. If we let the function equals 1, okay, if the function equals 1, you can see that means what? 1 dA, which is just a limit sum of all the delta A. So delta A means the small area, right? If we add all the small area together, it's just the whole area of the region R. Okay, so this is just the area of region R. So actually, if we let the function equals 1, whenever we have the function equals 1, the double integral is the area. Okay, I can give you this as a formula. So area in polar coordinate is A equals the function equals 1 here. Okay, 1, we don't have to write down. And then dA is R dr d theta. In Cartesian, it's just a dA, O dx dy. Okay, but just a function equals 1. So the area in polar coordinate is this one. Now let's take a look at example 3. We're going to find the area of some polar curves. In calculus 3, we did a similar problem, but it's very complicated. But right now, let's see if we do double integral. Can we make this easier? Find the area enclosed by this one. R squared equals 4 cosine 2 theta. Okay, R squared equals 4 cosine 2 theta. And then you can Google the graph, or you can use calculator. So I'm going to check quick. Graph of that one should be online. Yeah, you can find this graph online. R equals R squared. You can use also calculator, okay, everyone? So, yeah, online you can see a lot of graphs. I can share the screen with you. Okay. Can you see my share screen? I just Google, R squared equals 4 cosine 2 theta, so it's here. This is the graph. Okay, that's the graph. In the quiz, I will give you this graph. Don't worry. Now let me share my note. Okay, so let's draw the graph here. It's look like this, right? So first step, we know for the area, we need to set the function as 1. So it's going to be dr d theta. That's our first step. Right, okay. Actually, this the whole area is symmetric. We can treat this as, we can find the area of this one and multiple by 4 to get the whole area. Is that okay, everyone? So, because I didn't draw symmetric, but it should be symmetric graph. So we find the one part of the whole area, and then at the end we multiply by 4. For the angle, you can also find this area multiple by 2, but we like to make the problem easier. So we always like to see the boundary like 0, right? So for this one, definitely it's going to be theta going to be 0 to something, okay? And we don't know what is the angle here. We don't know what's the angle. So how do you find the angle? We make R equals 0. So we let this R equals 0 because it starts at origin here. So we let R equals 0, solve for theta. Okay, we want to do this. So it's going to be If r equals 0, for cosine 2 theta equals 0, that means cosine 2 theta equals 0, right? And that means 2 theta equals what? 2 theta equals
Pi over
pi.
2.
Yes, and what is theta? Pi over 4. Is that right? Okay. So firstly, we find pi over 4 because we need to know what's the limit for theta and r. So pi over 4. Okay, how do you find the pi over 4? Let r equals 0. And this is theta. Okay, how about r? R, you know, for r, I always like to draw a ray. So you can see r from what to what? Can you see r from what to what? 0 to,
Square root of 4 cosine 2 theta.
yes, correct. Okay, so now let's set up our integral. The area equals theta 0 to pi over 4. Actually, this is a1. At the end, we need to multiply by 4. Okay, at the end, we multiply by 4. So a1, a2, a3, a4, like this. So they are all the same. So let's calculate just one part. 0 to 4, that is theta. And what is r? R should be 0 to root of 4 cosine 2 theta. And here's 1, right? That's the area. And let's evaluate this one. So r dr is integral is just r squared over 2. Is that right? And r from what to what? 0 to square root 4 cosine 2 theta. Okay, and the d theta, theta from 0 to pi over 4. That's good. So in our, we have r squared, and then our boundaries has square root, and the square and the square root cancel out. So let's see. When you plug in r, it just becomes 4 cosine 2 theta, that's r squared, and divided by 2. And the minus 0, right? So 0 we don't have to write down. And this becomes 2. I take the 2 to the front. Okay, 0 to pi over 4. And the cosine 2 theta d theta. Integral of cosine 2 theta should be sine 2 theta over 2. Is that right? 0 to pi over 4 times 2. And the 2 cancel out. Okay. And next, plug in sine 2 times pi over 4. So it should be sine pi over 2. Is that right? And the minus sine 0. So the final answer is just 1. But this is not our final answer. Our final answer ever equals what? 4. 4 times a1. Okay? Just like this. I'm going to ask you to do one exercise. Okay, let's try. The most important part for this problem is here. Find the limit, right? After that, just evaluate. Double integral, pretty easy. Now let's see, exercise. This will be the quiz, okay? Find area enclosed by 1 leaf of this one. 1 leaf of the rose r equals 12 cosine 3 theta. I'm going to give you the graph, okay? Those 3 leaves, they are totally, have the area are totally same. Find the error by 1 leaf. So for 1 leaf, which leaf do you like to choose? You want to choose the left two, or you want to choose the right one when you do the problem? You like to choose this one, right? The right one. But when you do the problem, you can do just 1 and then multiply by 2 at the end. Okay, please try this.
Professor, why does the area equal 4 for the last problem?
Okay, this problem, we want to find the whole area enclosed, but we only find this one, number 1 is only this part. So you can see we have how many? We have 1, 2, 3, 4. It's like, yeah.
Okay.
yeah, that's why. And for this exercise problem, asks you to find the 1 leaf. So if we do this one, at the end we multiply by 2. Is that right? Just multiply by 2. Let's try this problem. You don't have to solve, just set up the integral. So basically, when we set up the integral, we just need to find the limit for r theta. Do you know how to find the theta?
Don't you set r equal to 0?
Yes, correct. What is your theta? Did anyone get the theta value?
Pi over 6.
Yes, correct. So it should be make r equals 0, solve for theta. That's how we find the theta, right? Actually, for this problem, the only thing we need to is just finding the theta. So it should be theta from what to what. And the error, we need to 2 times the double integral if we do this way, right? 0 to pi over 6. And r from 0 to 12 cosine 3 theta. Are you okay, Rowan? Did you get the same thing? Yes. Any question for this exercise problem? So similar, yeah.
I'm confused why we're doing this at all. If we can do it, if we can find the area of these roses without doing double integrals.
Oh, you mean you want to? So you can also do single integral like we did in calculus 3, but here it's just calculation. It's just an application of the double integral. So you like to try double integral. But if you want to do other way, that's fine. Yeah. If you still remember the formula, but here we don't need to remember the formula. For calculus 3, we need to memorize the kind of like a formula, right? Something like that. But actually they're the same thing, because when we evaluated that one, that is r squared over 2, right? So same thing, but here we don't need to memorize. Okay, it's just a double integral of dA. Double integral of dA, which is r dr d theta. So I think I like this way better. Yeah. Okay, so in the midterm, we will have similar thing, okay? Keep in mind. Next thing, we are going to do the last example in this section. Let's see. Example 4, I think, yeah. we want to evaluate this one. Double integral dy dx, and R is the upper semicircle. Bounded by. Okay, if I don't say upper, I just say upper. I just say bounded by, semicircular bounded by. We should also know how to draw the graph. Okay, this is the problem. So firstly, if we look at the function, do you know what is this function? Yes. What's the graph of that function? It is the, if you square both sides, this is circle, right? Circle. And the y equals that one, that means the upper half, okay? If it's negative, means lower part, lower half. This is our region R. And radius is 1. So from -1 to 1. Let's see. If we do Cartesian, there's no way to evaluate because we don't know how to evaluate this integral. Is that right? If it's we have y e to the y squared dy, it's okay, we can do u sub. But for this problem, if we want to do, firstly dy like a Cartesian, there's no way we can find, cannot solve. We don't know how to solve this. Cannot solve this integral. So we cannot do Cartesian, okay? Cartesian coordinate doesn't work for this problem. And also if we do Cartesian, we are going to, y going to be, it will be pretty complicated, okay? We have to do y from 0 to this one, and dx, x from -1 to 1, something like this, okay? So you can see this is circle, right? Even it's half circle, but it is also the part of the circle. So we like to use polar, okay? Polar coordinate. So polar coordinate is very easy to see from here. Is that right? R from what to, theta from what to what? Anyone can tell me what's the boundary for theta?
0 to pi.
Good, 0 to pi. And how about R?
0 to 1.
0 to 1. And how about the function? E to the what power?
1.
Okay, careful. X squared, y squared, x squared plus y squared in polar equals what?
Radius squared.
Yeah, r squared, r squared. Okay, so here is r squared. So this is general function. It's not just on the boundary, okay, not just on the circle. So it should be e to r squared. And what should we put next?
RD theta.
Perfect. Okay. So when we solve this, okay, so we can use u sub. Can you see? Okay, so actually, when you look at this one, if we do this, right, R, there's no theta. So that's going to be a number. There's no theta, it's going to be a number, so constant. And then actually the final answer are going to be, because pi is just the integral of d theta, pi times the integral of r e to the r squared dr, something like this. And this is calculus 1. I'm going to finish the problem, and just in case you forget to use sub, okay? But I think you should be okay. U equals R squared, right? And what's the du? 2R dr. So that means R dr is du over 2. Okay. So this integral equals to, I'm going to continue to with pi, okay? Pi times integral e to the u du over 2. So I take the 1/2 to the front. And the u from what to what? So u is R squared. So just plug in, train the bond. So for this one, R is 0, U is 0, R is 1, U is also 1, but be careful, okay? For other problem, the boundary may be changed. So integral of that one should be just e to the u, 0 to 1, and then plug in. So power 2, e to the 1 minus e to the 0, e to the 0, be careful, is 1. So that's the final answer.
Why are you able to use, why are you able to just put pi on the outside as a coefficient or whatever?
Okay, you can just leave the pi, you can just leave 0 to pi d theta always outside. You can always just evaluate this inside. So for example, when we evaluate inside should be 1/2 e minus 1, okay? So inside the integral, when we do use sub, should be this one. And because, I can tell there is no theta. Is that right? There is no theta. So the definite integral of this function will be just a number. It's going to be a number. Is that right?
Okay,
so,
yeah.
Yeah, so that's why I can
I got you.
take that out, and that's divide like an integral of d theta, which is pi. So I just simplified the calculation a little bit.
All right.
Yeah. Okay. But you can just leave, the constant inside, whatever you like. You can just do regularly. Here, I'm going to ask you to do this exercise. If I want you to evaluate this one, okay, Cartesian coordinate may work for this problem. Firstly, for this graph, I didn't give you the region R, right? What is given? The limits for x, y are given. Is that right? Can you, by using the limit of x, y, to sketch the region R? And then change this into polar. Because if we do Cartesian, it will be very difficult. First step, sketch the graph. Be really careful. This is very easy to make mistake. Is your graph a semicircle or quarter of a circle?
Quarter.
Yes. Y is from 0 to the half circle, right? Top circle. But if you look at the x boundary, x from what to what? x is from 0 to 1. Is that right? So we only have the right part. Are you okay, everyone? Be careful. This is the first step. If our region R is wrong, the whole problem will be wrong. Any question about this? Feel good? Okay. If my original problem is -1 to 1, there's the whole semicircle, right? Depends on the boundaries. And now please change this into polar and evaluate. I want to see the final answer. When we change into polar, is this problem easy? Travis, are you there? What did you get?
For final answer, I got pi/4.
Anyone get similar, different answer? Almost.
I got pi/8.
Yeah. So let's take a look. Be careful, Travis. So here is this integral should be, this should be r cube, right? And the final answer should be power 2 times, you know, r fourth over 4, so it should be 1/4. So final answer should be 1/8. Just be a little bit careful. Okay. Is that right? Okay. So you can see from this sketch the graph, okay, draw graph, and then change it into polar. If the region is circle or semicircle, whatever, just a polar. So next time I'm going to give you a summary for the, okay, give you a hint for the quiz tomorrow. So quiz, we are going to have 2 problems of double integral in Cartesian coordinate, okay? And the 2 problems in polar coordinate. And for the polar, one is just a, you know, regular, and the other one find the area of, you know, one loop, one leaf, those kind of thing. Find the area, and this is just evaluate. Okay, and then for the double integrals in Cartesian, I may give you dx dy and ask you to change into dy dx. Okay, so what do you know how to do that? Given this, draw graph and change the order, right? Okay, so Cartesian. And the second problem, I think, is just evaluation. Let me check quick. Oh, okay. 2 ways. So it's like a type 1. Type 1 and type 2. It just means dx dy and dy dx. So given region R, you just give me 2 ways to write down the double integral. So you don't need to solve, just write down double integral. So I think, yeah, those are all the quizzes problems we're going to have tomorrow. Are you okay, everyone? Any questions? Can feel free to ask me.
Yeah, I have a question.
Mhm.
So are we only evaluating the integrals for polar, but then we're only setting it up for Cartesian?
You mean for the quiz problem? I
Yeah.
will say, if I ask you to set up, just set up. If I ask you to evaluate, I will say evaluate.
Okay.
So in the problem, yeah. So be prepared. Yeah, should.
Or the one that we switch from dx dy to dy dx, are we given the graph or do we have to graph it based off the limits?
Based on the limit, yeah.
Okay.
Mhm. Okay. Any other questions? In the homework, definitely you will find similar problems. You know, if you finish all the homework, you should be fine. Yeah. There are some similar problems, you can find them. So if no question, we can stop here today, and tomorrow we start a little bit of 15.4, and then we will have the quiz. Okay. See you tomorrow, everyone. Bye-bye.
Thank you.
Mhm.
Thank you.
Yeah, bye.
Thank you.
Mhm.